Good evening, students. How are you all? Welcome to session 2 of Polynomials. I'm Kanika ma'am, your mathematics teacher. So, children, in the previous class, we had started with polynomials. So, I had given you a small introduction of the same. And also, we had discussed a few questions of NCERT. So, we're going to proceed further today. So, before I start with anything new, I would like to first discuss the previous, whatever I've discussed in the previous class. So, let's quickly revise the same. So in the previous class, we had discussed about algebraic expressions. Algebraic expressions are those expressions where we have variables and the variables have the exponents as rational numbers. But when we restrict the exponents just to whole numbers, that means when we have expressions where we have the variables having exponents only the whole numbers, they become polynomials. So they're called polynomials. So an algebraic expression can have exponents as rational numbers. However, a polynomial is an algebraic expression in which the exponent on any variable is a whole number, or we may say non-negative integers. So whole numbers, they start from 0, 1, 2, 3, 4 and so on. So that's the difference between algebraic expressions and polynomials. Algebraic expressions have rational numbers as the powers of the exponents, and polynomials, we just have whole numbers as powers of the exponents. For example, we have this polynomial 5x cubed plus 3x plus 1. So it's a polynomial since we can see that the exponents here are 3 and 1. So they are whole numbers. Now also we had discussed yesterday degree of the polynomial. So for a polynomial in one variable, the highest exponent on the variable in a polynomial is degree of the polynomial. This means that that if we have one variable, like in this case we have x square plus 2x plus 3, the variable having the highest power is called degree of the polynomial. In this case we have the highest power as 2, so the degree of this polynomial is 2. Now let us proceed. Types of polynomials. Now the polynomials, they can be classified on the basis of number of terms they have or on the basis of the degree of the polynomial. So if a polynomial has just one term, we are going to call it a monomial. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. Now we are classifying the polynomials on the basis of degree. So we have constant polynomial here. A polynomial whose degree is 0 is called a constant polynomial, and the standard form is ax raised to the power 0. So if I have a number like let's say 25, that's a constant polynomial. The degree of this polynomial is 0. However, we are though 0 is a constant polynomial, we are not considering it as a constant polynomial. Rather, we consider it as a special polynomial named as 0 polynomial. So 0 is another polynomial. Though it is a constant polynomial, we've given a special name to it, that is 0 polynomial. Okay. Now for the we've discussed constant polynomial. Polynomial having degree 0 is called constant polynomial. And 0 is itself a constant polynomial, but then we name it as 0 polynomial. Now, linear polynomial. A polynomial whose degree is 1 is called a linear polynomial. A polynomial whose degree is 2 is called a quadratic polynomial. So degree 1, it's a linear polynomial. Degree 2, it's called a quadratic polynomial. And when we have degree 3, it's called a cubic polynomial. Also, we had discussed about the zeros of the polynomial. For example, if I have a polynomial x square minus 3x plus 2, that particular value of x, which is going to make the value of the polynomial 0, is called 0 of the polynomial. For example, if I put here x is equal to 1, if I put x is equal to 1, I'm going to get p of 1. That means the value of the polynomial at 1 as 1 square minus 3 into 1 plus 2. So this will become 0. So at x equal to 1, the polynomial, its value is 0. So we can say x equal to 1 is 0 of the polynomial. Now coming to geometric meaning of the zero of the polynomial. Now geometrically, zeros of the polynomial are the points where its graph cuts x-axis. For example, if I have this polynomial, I have made graph of the same. It is cutting x-axis at one point, so it has 1, 0. So the points at which the graph cuts x-axis, they're called zeros of the polynomial. Here the graph is cutting x-axis at 2 points, so there are 2 zeros. Here the graph is cutting x-axis at 3 points, so there are 3 zeros here. Now please notice, in general, polynomial of degree n has at most n zeros. A linear polynomial has 1 0. A quadratic polynomial has at most 2 zeros. A cubic polynomial has at most 3 zeros. Also, children, we had discussed a few questions on based on NCERT. These are NCERT questions. First exercise of polynomials, where we had discussed the number of zeros this particular polynomial has. So wherever the graph is going to cut x-axis, that would be 0 of the polynomial. For example, in this case, please notice this graph is not cutting x-axis at all. So we don't have any 0 for this polynomial, no 0 at all. Here the graph is cutting x-axis at a single point. So in this case, it has only 1 0. Also, we had discussed yesterday the relationship between the zeros and the coefficients of the polynomial. So specifically, we had discussed for the quadratic polynomial. For a quadratic polynomial, the standard form is given by ax square plus bx plus c. This is the standard form for the quadratic polynomial. It's a quadratic polynomial, so degree is 2. So in this case, we have 2 zeros of this polynomial. Let us name the zeros as alpha and beta. Now, alpha plus beta, that means the sum of the zeros is same as minus b upon a. That is minus the coefficient of x upon the coefficient of x square. So, sum of the zeros is same as minus b upon a. So, that's the relationship between the sum of the zeros and the coefficients of the polynomial. In the same way, if I take alpha beta, that means I'm multiplying these two zeros, the product will be same as c upon a. So I'm talking about this c, that's the constant term, upon the coefficient of x square. So now we have to use these two relations between the zeros of the polynomial and their coefficients. So sum of the zeros is same as minus b upon a. Product of the zeros is same as c upon a. So we had also discussed questions like this in the previous class, where a polynomial was given to us and we were supposed to find the zeros of the polynomial, and we were also supposed to verify the relationship between the zeros and the coefficients. So find the zeros. Once you get the zeros, you have to verify the relationship between the zeros and the coefficients. That means you need to check whether the sum of the zeros is coming out to be minus b by a and the product of the zeros is coming out to be c upon a. So children, all this we had discussed in the previous class. Now let us proceed further. So before we proceed to the next concept, I want to discuss one more question of this type, this one. Here we have to find the zeros and zeros of this polynomial, and we have to find the relation, and we have to verify the relationship between the zeros and the coefficients. So please notice here, this is u square term, this is u term, there is no constant term. So in order to find the zero, we are going to take this 4u square plus 8u is equal to 0. Now we are going to take out common, whatever is common. Like we have 4 common, we have u also common here. And then we have u plus 2 inside bracket. From this we can say either 4u is 0 or u plus 2 is 0. So if we have product of two numbers 0, either one of them is 0 or both are 0. So we have 4u equal to 0 or we have u plus 2 is equal to 0. From here we can say either u is 0 or u equal to minus 2. So these two are zeros of the polynomial. Now please notice, we have to verify the relationship between the zeros and the coefficients. I hope you've all understood till here. Okay. Now, the sum of the zeros is given by minus b upon a. Now, if I compare this with the standard form, if I take this 4u square plus 8u with the standard form is written as ax square plus bx plus c. Please notice there is no constant term. So we are going to write 0 in place of that. If I add 0 to something, it will not make any difference. So for my convenience, I have written 0 here. So a is 4, as I can see, a is 4, b is 8, and c is 0. The sum of the zeros, as we can see, is 0 plus minus 2. 0 plus minus 2, that is minus 2 only. And minus b by a, let us see what is minus b by a. Minus b by a is minus 8 upon 4. That's again minus 2. Now we have got the sum of the zeros both as minus 2. So that means we can say that the sum of the zeros, let's say alpha plus beta, is same as minus b upon a. So we have verified the first relationship between the zeros and the coefficients. Now let us talk about the product of the zeros. So we have the product of the zeros, 0 multiplied by minus 2. 0 into minus 2 would be 0. 0 multiplied by any number is 0 only. And this should be same as c upon a. Please notice alpha beta is equal to c upon a. We have just discussed this. I'll show you. Here. Alpha beta is equal to c upon a. Now, c upon a is 0 upon 4, that is 0. So product of the zeros is same as c upon a. Alpha beta, the product of the zeros is same as c upon a. So we have verified the relationship between the zeros of the polynomial and their coefficients. I hope children, you've understood this, and this question with a lot of parts we had discussed yesterday also. Now, I told you yesterday that in the that we're going to learn today's class how to form an equation when the zeros are given to us or when we know the sum of the zeros and the product of the zeros. So today we are going to learn formation of quadratic polynomial with given zeros. So if we have alpha and beta, they are two zeros of the quadratic polynomial, then the formula to construct the quadratic polynomial is given by x square minus alpha plus beta into x plus alpha beta. Now please notice this means that if you have two zeros of a quadratic polynomial and the zeros you already know the zeros. And now you have to form the quadratic polynomial with those two zeros. How you are going to do that? You will take x square minus sx. S is sum of the zeros. Just see, alpha plus beta I've written, that is actually sum of the zeros. And alpha beta is the product of zeros. So I'm just denoting it by s and p respectively. So the formula to construct the quadratic polynomial is x square minus sx plus p. If you know the zeros for a quadratic polynomial, but then you don't know the polynomial, you have to form a quadratic polynomial. You will take x square minus sum of the zeros times x plus product of the zeros. That is k times of x square minus sum of the zeros x plus product of the zeros. Please notice we have written k here. That's just to be on safer side. If anything is common, we can take out that common. Any particular number is common, we can take it out. Now, if a quadratic polynomial is given in standard form, we can find the sum and the product of the roots using the coefficients of x square, x and constant term as we discussed earlier. So, we've just discussed how to form the quadratic, when a quadratic polynomial is given to us, how to find the sum and the product of the roots. Now, let us discuss this. We have a question. Form the quadratic polynomial whose zeros are 2 and 3. So please notice zeros are given to us 2 and 3. Sum of the zeros is 2 plus 3, that is 5. This we know, we can solve it. Product of the zeros is 2 times 3, that is 6. We know the product of the zeros. So the formation of the quadratic polynomial is k times, you can either write k times, and even if you don't write, that's okay. So x square minus sum of the zeros plus the product of the zeros. So that is x square minus sum of the zeros. Sum is 5. So I've replaced s by 5. Product of the zeros is 6. So I'm going to replace product by 6. So this is the required quadratic polynomial where we have sum of the zeros x and product of the zeros 6. Now, let us discuss this. Find a quadratic polynomial. We have to form a quadratic polynomial, each with the given numbers and as sum and the product of its zeros respectively. So the numbers which are given to you in this question, they are the sum and the product. So this is the sum and this is the product. Now we know how to construct a quadratic polynomial. We have just learned it is x square minus sum of the zeros. We'll times it by x plus product of the zeros. So that is x square minus sum, that is 1 by 4 x plus product. So we can write it as minus 1. The product is minus 1, so I've written minus 1. Either you can leave it here or you can simplify it. Take the LCM. The LCM here is 4x square minus x minus 4 upon 4. So the LCM is 4. Once you take the LCM 4, you will get in the denominator 4x square minus x minus 4. Now, even if you don't write this, that's okay. It will not make any difference. So you can just write required polynomial is 4x square minus x minus 4. That's the required polynomial. I hope children you've all understood this. So even if you've not understood, that's okay. We'll discuss a few more questions of similar type. Now again, we have two numbers, root 2 and 1 by 3. This is given to be the sum. This is given to be the product. We have to solve, we have to find a quadratic polynomial having sum as root 2, product as 1 by 3. So we know the formula. It's x square minus sx plus p. X square minus sum of the zeros is given by root 2 and the product we know is 1 by 3. Now here we have 1 by 3. You can either leave it here or you can take the LCM and simplify this. So I'm going to take the LCM. LCM is 3. I will get here 3x square minus square root of 2x plus 1. 3x square minus square root of 2x plus 1. So even if you don't write this 3, that's okay. It will not make any difference. So you can straight away write a required polynomial is 3x square minus root 2x plus 1. So that's the required polynomial. Okay, children, I hope you've understood this. Let's discuss the next one. Okay, so this is very easy. We have 0 as the sum and p as the product is root 5. So we know the formula x square minus sx plus p. So x square minus 0. In place of s, I am writing 0. In place of sum of the zeros, I am writing 0. It's given to me in the question. So 0 times x plus root 5. P is root 5. So 0 times x will give you 0 only. So you have x square plus root 5. This is the required polynomial. So even if you don't write this 0 into x, that's 0. Even if you remove it, that's okay. It will not make any difference. Now comes the next one, 1 and 1. So this is the sum, this is the product. We know the formula, x square minus sum of the zeros into x plus product of the zeros. X square minus 1 into x plus 1. So I have replaced s and p by 1 and 1. So this is x square minus x plus 1. 1 into x is x only. Even if you don't write 1 here, that's okay. It will not make any difference. So this is the required polynomial. Okay, so children, I hope you've understood this. Yes, it's very simple and you just have to learn the formula and that's all. Just put the values of sum and the product. If sum and the product is given to you, you can just straight away pick up the values from the question and you have to you can put it. If the sum and the product is not given to you, the zeros are given to you, you can solve for sum and product and then you can put it here. Now the next one, we have 4 and 1. This is the sum, this is the product. So the formula is x square minus sum of the zeros into x plus product of the zeros. That is x square minus sum. Sum is your 4x plus 1. So this is the required polynomial where we have sum as 4 and product as 1. Now we are going to do some questions based on sum of the zeros and the product of the zeros using this relationship. So before we start with those questions, so just see, if you have x square minus 3x plus 2, let's say you have this particular polynomial, and since it's a quadratic polynomial, we can observe that there are two zeros. Let's say we have zeros alpha and beta. So if you want to solve for sum of the zeros, please notice, if you just want sum of the zeros, you don't want the zeros, you just want the sum of the zeros, you know it's minus b upon a, and you also know that the product of the zeros is c upon a. So we are going to first compare the polynomial with the standard form, that is ax square plus bx plus c. So from here we can see that a is 1, b is minus 3, a is 1. Nothing is here, that's 1. So b is minus 3, c is 2. So sum of the zeros, alpha plus beta, is minus b upon a, that is minus 3 upon 1. That's positive 3. And product of the zeros is c upon a, we know. So we can write the c as 2. A we know is 1. So that is 2. So finally, from the polynomial itself, the original polynomial given to us was x square minus 3x plus 2. So the sum of the zeros here is minus 3 upon 1. That's minus b upon a actually. That's 3. And the product of the zeros is 2. So if a polynomial is given to you, you don't want the zeros, but then you want the sum and the product of the same, then you can solve it directly from the polynomial. So let us discuss a few questions based on this. So these are a bit twisted questions. So if 1 0 of the polynomial px, 3x square minus 8x plus 2k plus 1 is 7 times the other, find the zeros and the value of k. So please notice this 2k plus 1 is the constant term. This is the polynomial given to us. I'll just write it again. 3x square minus 8x plus 2k plus 1. If I compare this with the standard form, that's ax square plus bx plus c. From here I can see that a is 3, b is minus 8, and c is 2k plus 1. Now it's a quadratic polynomial, so we know it has two zeros. It's given to us in the question that if 1 0 of the polynomial px is 7 times the other. So instead of taking alpha and beta, we can take that 1 0 is alpha, so the other one is 7 times the other, that is 7 alpha. Now using this information, we have to find this, then find the zeros and the value of k. So we have to find the zeros, that is alpha and 7 alpha. These are the zeros which we have taken. And we also have to find this unknown value, that is k. Now, if I take the sum of the zeros, let's say if I take the sum of the zeros, that is alpha plus 7 alpha in this case. So sum of the zeros is given by minus b upon a. Minus b upon a is minus 8 upon 3. So actually this is same as this. So we can write here alpha plus 7 alpha is equal to minus 8 upon 3. I'm directly writing positive 8 by 3 in the next step. So this is 8 by 3. Now if we combine these two, we are going to get 8 alpha here equal to 8 by 3. 8 and 8 will get cancelled. We will then have alpha equal to 1 by 3. So we have alpha equal to 1 by 3, and we know that the other 0 is 7 times this one. So it is actually 7 alpha. So the other 0 would be 7 into 1 by 3, that is 7 by 3. So please notice, in the question they asked us to find the zeros. We have solved for the zeros. We are getting 1 by 3 and 7 by 3. Now we have to solve for the value of k. Now the value of k here, we know c is 2k plus 1. We also know that product of the zeros is given by c upon a. So product of the zeros here is, this is 1 0, this is the other 0. Product of the zeros here is given by c upon a. So this is 7 upon 9. This is given by 2k plus 1 upon 3. I am writing 2k plus 1 in place of c, and I am writing 3 in place of a. So this is 2k plus 1 upon 3. It's 2k plus 1 upon 3. Now, we can write this as 3 into 3. 9 can be written as 3 into 3. Then we have 2k plus 1 upon 3. One of the 3's will get cancelled, and this 3 I'm going to take on the other side and it will get multiplied. So we will have 7 is equal to 6k plus 3. Now we need to solve for k. So I'm going to take 3 on the other side. We'll get 7 minus 3, that is 6k. So we have 4 is equal to 6k. 6 you can take on the other side, it will get divided, and you will get 4 upon 6 is equal to k. I'm writing it here. You can get 4 upon 6 is equal to k. Further, you can simplify also. You can write k as 2 by 3. So the value of k is 2 by 3. Children, I'm repeating the entire question again. Please be very, very attentive because we are going to do similar questions after this. So I'm starting right from the beginning. Just give me 1 minute. Children, just excuse me for a minute. Okay, so we were discussing this question. I'm repeating right from the beginning. Please be very attentive. If one zero of the polynomial px is 7 times the other zero, we have to find the zeros of the polynomial. Now I'm writing the polynomial again. That is 3x square minus 8x plus 2k plus 1. This 2k plus 1 is the entire constant. I'm going to okay, so can you see the slide? Yes, all right. Now I'm going to compare this with the standard form, that is ax square plus bx plus c. So from here we can see that a is 3, b is minus 8 and c is 2k plus 1. Now we have to find the zeros of the polynomial and we also have to find the value of k. So the first step is I'm going to solve for the zeros. Now let us take the zeros as alpha and 7 alpha. It's given to us in the question that one zero is 7 times the other. So if I've taken one as alpha, the other one would be 7 alpha. We also know that the sum of the zeros is given by minus b upon a. So that is minus 8 upon 3. I put minus 8 in place of b and I put 3 in place of a. So it's minus 8 upon 3. So this can be written as 8 alpha and this is same as minus 8 upon 3. So I'm writing it as 8 upon 3 in the next step. Minus will become plus. You can cancel out these 8s and then you will get alpha is equal to 1 by 3. Now one of the zeros here is alpha, that is 1 by 3. And we know that the other one is 7 times of alpha. So the other 0 would be 7 times of 1 by 3. That is 7 by 3. Now we've got the zeros as 1 by 3 and 7 by 3. So we are done with first part of the question. In the next step, we are going to solve for k. Now we already know that the product of the zeros, alpha and 7 alpha, if I take, the product of the zeros is same as c upon a. So now I'm not using alpha and 7 alpha. I'm using the values because I already know 1 by 3 and 7 by 3. They are the zeros. So I am writing this as 1 by 3 and this one as 7 by 3. So this is same as c upon a. C is 2k plus 1. A is 3. So this is 2k plus 1 upon 3. From this equation, we are going to solve for k. So 3 and 3 we can cancel. And then we have 7 upon 3 is equal to 2k plus 1. This 3 we are going to take on the other side and it will get multiplied. So we have 7 is equal to 6k plus 3. From here we solve for k. We are going to take 3 on the other side and we will get 7 minus 3 is equal to 6k. Then we will get 4 is equal to 6k. In the next step, we'll take this 6 on the other side and we will get 4 upon 6 is equal to k. And once we simplify this, we'll get k is equal to 2 by 3. Finally, we've solved for the value of k also, that is 2 by 3. I hope children you've all understood this. Now let us discuss the next one. I don't know why I'm facing this problem again. Now after this we'll do this question, but already this wait, just give me 1 minute. So this one we've already discussed. Let's discuss this one. Children, I hope you can see the slide, the question on the screen. This question, if alpha and 1 by alpha are zeros of the polynomial, you can all see this. Okay. All right. So we have, if alpha and 1 by alpha are zeros of the polynomial 4x square minus 2x plus k minus 4, you have to find the value of k. We have two zeros for this quadratic polynomial. It is 4x square minus 2x plus k minus 4. This is the polynomial given to us. The first step is we are going to solve, we are going to compare this with the standard form, that is ax square plus bx plus c. So here a is 4, b is minus 2 and c is k minus 4. We have two zeros here, alpha and 1 by alpha. These are the zeros given to us. Now we have to find the value of k. In order to find the value of k, k is given in c. So we can make use of c upon a, that is product of the zeros. So I'm not using sum of the zeros concept here. I'm using the product of the zeros. So product of the zeros, we have alpha into 1 by alpha, and the product of the zeros is given by c upon a. So it's very simple. Alpha and 1 and alpha will get cancelled here. We'll be just left with 1. 1 is equal to c upon a. A you can take on the other side and then you are going to get here a is equal to c. Now a is 4 and this is c. So a I have written 4, c is k minus 4. If you take 4 on the other side, you will get 4 plus 4 is equal to k. And finally, we have k is equal to 8. That's the value of k. Very simple. I'm repeating this. This is the polynomial given to us. We are going to first compare the polynomial with ax square plus bx plus c. And from here, we can observe that a is 4, b is minus 2 and c is k minus 4. It is also given to us that alpha and 1 upon alpha are zeros of the polynomial. So if I use the sum of the zeros concept, it may not be useful. So I'm going to use product of the zeros concept because I actually need to solve for k. K is occurring here in c. So that is why I've taken product of the zeros, that is alpha into 1 upon alpha as c upon a. Now alpha and alpha will get cancelled. We will just be left with 1 and then we have c upon a. A we can take on the other side and we will get a is equal to c. Then we know a is 4 and c is k minus 4. So I have replaced a by 4 and c by k minus 4. This minus 4 I am going to take on the other side and this will become 4 plus 4, that is k. So finally we are getting k as 8. I hope you've all understood, children. So let's discuss one more question. If sum of the squares of the zeros of the polynomial, please notice sum of the squares of zeros of the polynomial is given to us. So the polynomial given to us is 5x square plus 3x plus k. The first step is, let's quickly take, in fact alpha beta is also not, we can take here ax square plus bx plus c. So what we have done, we are comparing this with the standard form. So from here we get a is 5, b is 3 and c is k. Now sum of the squares of the zeros. First of all, we know it's a quadratic polynomial, so it has two zeros. Let us take the zeros as alpha and beta. And if we take the squares of alpha, beta and we add them, this is sum of the squares of the zeros. Sum of the squares of the zeros. So it's not alpha plus beta whole square, it is actually alpha square plus beta square. You take the squares, alpha square and beta square, and then you add them. Now sum of the squares of the zeros of this polynomial is minus 11 upon 25. This is given to be minus 11 upon 25. So we are going to make use of this. And we have to find the value of k. Now how to proceed in such questions? It's very easy. We already know alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. So this is of the form a plus b whole square. This we have done in grade 8. It's a square plus b square plus 2ab. Now alpha plus beta. What is alpha plus beta? The sum of the zeros, that is minus b upon a. It's minus 3 upon 5. So I'm going to replace this by minus 3 upon 5. It's minus 3 upon 5 square. And then we have alpha square plus beta square. This is minus 11 upon 25. And then we have 2 times of alpha beta. This alpha beta is the product of the zeros. So the product of the zeros, alpha beta, is c upon a. That is k upon 5. So this is 2 times of k upon 5. Now in the next step, we are going to write this as 9 upon 25. This is minus 11 upon 25. And then this is 2k upon 5. Now in the next step, we are going to take this on the other side and it will get added. So we will get 9 upon 25 plus 11 upon 25 equal to 2k upon 5. Now we know that the denominators here are same. We can straight away add the numerators. So we'll get 20 upon 25 is equal to 2k upon 5. This can be cancelled. These two I'm cancelling by 5. We'll get 4 here and then 5 here. So we have 4 upon 5 is equal to 2k upon 5. 5 and 5 will get cancelled and then we have 4 is equal to 2k. 2 we can take on the other side and it will get divided. So we have 4 upon 2 is equal to k, and finally we have k is equal to 2. Finally we have k is equal to 2. Children, I am repeating this question right from the beginning. I'm explaining. If the sum of the squares of the zeros of the polynomial 5x square plus 3x plus k is 11 upon 25, we have to find the value of k. So the polynomial given to us is 5x square plus 3x plus k. We are going to compare this with ax square plus bx plus c. So a is 5, b is 3 and c is k. We are going to take the zeros of the polynomial as alpha, beta, and it's given to us sum of the squares of the zeros. That means we are going to take the square of alpha, square of beta, and we are going to add them. It is sum of the squares. So you take the squares and then you add. It is given to be minus 11 upon 25. Also, alpha plus beta, that is sum of the zeros, is minus b upon a. So that is minus 3 upon 5. We also have the product of the zeros, alpha, beta, c upon a. That is k upon 5. Now we have to solve for k. Now alpha plus beta whole square is same as alpha square plus beta square plus 2 alpha beta. Alpha plus beta is minus 3 upon 5. So I have replaced this by minus 3 upon 5. And alpha square plus beta square is minus 11 upon 25. So I have replaced this by minus 11 upon 25. Alpha beta is the product of the zeros, which we know is k upon 5. So we are writing k upon 5 in place of alpha beta. In the next step, we have squared this. Minus 3 upon 5 whole square is 9 upon 25. and then rest of the terms will remain same. That's 11 upon 25 plus 2k upon 5. Now this minus 11 upon 25 will go on the other side and this will get added. So we have 9 plus 11 upon 25 is equal to 2k upon 5. Now we have 25 here as the common denominator, so we need not calculate the LCM, not required in this case. And then we have 9 plus 11, that's 20. And we can cancel numerator and denominator by 5. So we have 4 here and 5 here. So we have 4 upon 5 equal to 2k upon 5. This 5 and 5 will get cancelled. And then we have 4 is equal to 2k. 2 we are going to take on the other side and it will get divided. So we have 4 upon 2 is equal to k. Finally, we have k is equal to 2. I hope children you've all understood this. Let's discuss one more question. If 1 0 of the quadratic polynomial 2x square minus 3k plus 1x minus 9 is negative of the other, find the value of k. So we have this polynomial 2x square minus 3k plus 1 into x minus 9. We are going to compare this with ax square plus bx plus c. So a is 2, b is minus 3k plus 1 and c is minus 9. It's a quadratic polynomial, so we know it has two zeros. 1 0 of the polynomial is negative of the other. This is given to us. It's negative of the other. So if 1 0 is alpha, the other one is minus alpha. It's very simple. One is negative of the other. So if I'm going to take one as alpha, the other one would be minus alpha. Now we need to solve for k. So we have here alpha plus minus alpha. Please notice I'm taking sum of the zeros here. That is same as minus b upon a. The sum of the zeros is minus b upon a. So alpha plus minus alpha is 0. This will become 0. 0 equal to minus b upon a we have. Now if you take this here, what you're going to get? 0 times of a, that is 0. 0 equal to minus b, or you can say b is equal to 0. Now we need to solve for k. So we have actually made it very simple. Take this b and put it here. It's minus 3k plus 1 is equal to 0. Then you are going to get 3k plus 1 is equal to 0. 1 you can take on the other side. You will get 3k equal to minus 1. And finally k is minus 1 by 3. So it's very easy. We have got the value of k as minus 1 by 3. So children, I am repeating this. If 1 0 of the quadratic polynomial 2x square minus 3k plus 1 x minus 9 is negative of the other, find the value of k. This is the polynomial given to us. We are going to compare this with the standard form. So we have ax square plus bx plus c. So we can see here a is 2, b is minus 3k plus 1 and c is minus 9. Now we have two zeros here and it's given to us that 1 0 is negative of the other. So if 1 0 is alpha, the other one is minus alpha. Now we are going to take sum of the zeros here. The reason behind taking sum of the zeros here is that we need to solve for k. So we know sum of the zeros is minus b upon a. That is why we have taken sum of the zeros, because k is occurring here in b. Now alpha plus minus alpha, that is sum of the zeros, is minus b upon a. This you are going to get as 0, that is minus b upon a. A you can take on the other side, it will get multiplied and you will get 0 equal to minus b. That is actually b equal to 0. So b is this. In the next step, I have replaced b by minus 3k plus 1 equal to 0. We have written. Now this is 3k plus 1 equal to 0. I've taken this minus. You can just say that minus we are taking on the other side and it will disappear because 0 divided by minus 1 is 0. Now 1 we are going to take on the other side. It will become negative 1. And 3 we are going to take on the other side. It will come in the denominator. So finally the required value of k is minus 1 by 3. Alright children, so I am winding up here. Children, please, before you come for the next class, go through these questions very well. Wherever you have a doubt, you can ask me in the next class. So tomorrow we'll discuss a few more questions based on sum of the zeros and the relationship between sum of and the product of the zeros.